Hello and welcome back to the channel, and in today's episode I'm going to show you how to recreate Mario Bros in Godot. Of course, this is not a perfect copy of a game because it would be really too much to recreate, so we have just the first level and some features are missing, but overall I believe this is really great. We will be able to shoot, to travel through the underground. Somewhere here there should be uh, that flower that allows you to shoot. Oh, here it is. Now you should be able to shoot the fireballs, which is really great. And of course you can finish the level by jumping on a flagpole. So that's what we are going to do. Let's see. Oh, there's small issue, but we'll fix it. Along. So yeah, come and join and let's recreate Mario Bros. And Godot together. Let's set up our project. I'm gonna go for a new, and I'm gonna browse and find a suitable place for it. So let's create a new folder called this Mario Bros. Tutorial, and select current folder, create and edit. Okay, let's switch to 2D, and as per usual I'm gonna create main node here, and I'm gonna save it. Let's create new folder scenes, and let's save it there. Also, let's designate it as a main node, set as main scene. Okay, and then we will bring in all of the assets. So let's create new folder, assets, just grab everything that we need, and you can find all of these in the code repository. So let's bring this here and here. Let's quickly take a look at the sprites that we have available here. So we have mushroom that should give you more life, but I'm not gonna write the lives manager. As I said, this tutorial is gonna be very long, and I did not implement complete set of features, but I believe that you can finish it up on your own. We have some decorations, the castle, the bricks, the fireball, empty block, the coins, the Goombas, the Koopas, which are our enemies, and then lots of Mario sprites and Mario animations, some mystery blocks, the flowers, and underground blocks. So that's pretty much all of it. Okay, let's start by going to project settings and setting some stuff up. First, let's find window, and here on the mode we're gonna set to canvas item when it comes to stretching. And then I would really like to get my hands on the input map. So let's set up all of the inputs already. So left, right, jump, down, and shoot. And this is going to be A, D, space, S, and left control. But you can set it up any way you like it. Okay. And this is, oh no, I would also like to change one other thing. And this is the color of the background. So let's go to general setting, search for clear, and in rendering environment you will find default clear color, and I am going to change this to a value I already have prepared, and this is 049CD8, which should turn into, oh, come on, 049. Why can't I change it? The fuck? Let's do hex again. Okay, let's just find something bluey then. Should be... Let's see. Something nice and blue. Yeah, okay, I can live with that. It's pretty close. So now if we run it, we get everything blue. Okay, so we're pretty much done with the setup. In the next section, we'll work on our tile map. We need to start working on our tile map. So let's get one here. Tile map. We will need a new tile set here, and our job is to bring the tiles that we need here. So definitely the brick, and we will need also the, oh no, we don't need a brick. Actually, we will work on it as a separate node, but ground block and hard block, and the same goes for underground block and underground brick. Okay, this is looking good. So yeah, let's get this party started by grabbing a ground block, and let's just start working on it. Let's see, this is a setup. I would like to go to Tilemap here, and then I should be able to select it and start drawing. And here we go, we have a little bit of ground here. The one problem I would like to also address is that probably we should go to project setting and find a filter for the textures, and default one is, I believe, nearest. So now it's not blurry, but rather crystal clear. Oh, and it pops up right here. Okay, but that's not a problem. We will set it up to show correctly soon. Let's just check the tile size. This is 16 by 16. This is all correct. Okay, so that wasn't much of a work right now. But one thing that we will have to do, and you have to remember about, is that right now this is just a set of sprites on the screen, and if we add a character here, it will just fall right through it because there's no collision for a tile set. Let's go to physics layers, let's create one, and we have to start working on our physics layers. So the first layer is going to be player. No, I love to rhyme. And then the second one is going to be our ground. So let's go to project settings. Let's search for 2D physics. This is player. This is a ground. Actually, as we are here, we could probably set up all of the layers. So let's see, ground, enemy. There's a special koppa stomped layer, which is separate. Obstacle, bonus, and a fireball. So we have 7 layers here: player, ground, enemy, koppa stomp, obstacle, bonus, and fireball. Okay, and with this minimal setup, in the next section we can actually start working on our player. That one's going to be good. So this is the time where we can start working on our player. So let's do scene, new scene, other node, character body 2D, and I'm just going to name this player. And we will need some stuff here. So let's start by adding an animated sprite. We will also need area 2D, and stay with me, there's a reason for it. Let's start by setting up the sprites. So animation, sprite frames, new sprite frames, and let's start naming those. So let's start by adding small idle animation. So searching here, I can filter to small, and there's Mario small idle. Perfect. And let's save this. And I will add a collision shape, and let's start by adding collision shape 2D, and I am going to name this body collision shape. And here I will add another collision shape and name this area collision shape. And you might be wondering why I'm doing this like that, because it is very easy to create the proper movement for our player using character 2D with move and slide. But then it's a little bit harder to detect some collisions while using the physics movement provided by character body. That's why I'm additionally adding this area 2D to handle some collisions. So I am combining here two approaches to detect the collision. Okay, and we can create a new rectangular shape. And what I am going to do is actually, I am going to save this shape. Let's see, this should be 12 and 16, and I am going to save this because we will have to switch the collision shapes between the big Mario and small Mario. So let's save this. Let's create new folder, resources, and new folder here, collision shapes, and I'm just going to call this small Mario collision shape. Perfect. And here I can just quick load and reuse that shape, and everybody's happy right now. Okay, it is time. The time to start coding, and there's gonna be a lot of it. So let's go here. Let's create new folder, call this scripts, and open, and we get something here, right? So this is generated by Godot, and of course the problem is we're not saying anything, and we don't even instantiate our player. So let's fix everything, and I'm going to start by adding camera 2D. And let's configure the camera because I would like for it to have a little bit of zoom, precisely 2.75. The position is 0, 0, so that's correct. And now that I'm looking at it, at the position of my camera, probably we'll need to move the Tilemap a little bit, but it is, the Tilemap itself is positioned in 0, 0, which is fine. So instead, what I am going to do is I am going to move those ground blocks. So I am going to move them, let's see, let's select this. I'm going to move them somewhere here for now. Okay, so the it should be 3 blocks high, at least for now. And this is just for us to walk on. We will definitely fix it up when we're building the whole level, the whole world. And then the last thing is to check the collisions. So we are a player and we are colliding with the ground. Okay, and then I can just leave this and say instantiate scene here player, and we're following through. That's what I do not want. So let's see again. Collision layer 2, collision mask 1. This is correct. Oh, I know what we didn't do. So we defined the physics layer, but we did not assign any tiles to it. So let's go to tile set, and then let's go to paint, and then we have to select the property, which is physics layer. You have to paint each and single tile so that it is collidable. Is this a word? Collidable? Yeah, okay. Cool. And now, as you can tell, we have the Mario working. But if you take a look at the code, it is not working with WSAD, but with the arrows on the keyboard. Sorry. Because this is how our code is structured, right? It is detecting UI left and UI right and UI accept, which are the left arrow, right arrow, and the space. But hey, we have something going here. Okay, so I'm gonna say the next part should be us setting up the movement properly and also animating our wonderful, beautiful Mario. So that's what we're going to do in the next section. Okay, let's start working on our player, and I am going to start by basically removing everything. Let's start by adding the class name. And I am going to define already an enum describing the mode in which our player is, which is going to be his rare small, either big, or shooting. Okay, then let's get some references here. So let's go here, and we'll need the reference to animated sprite. We'll need the reference to area collision shape and body collision shape, because we will be changing those as needed when we go from small to big. So I can just say here references, and then we need to define some variables for the locomotion of the player. So let's do export group locomotion, and let's add that export group here. So this is just grouping your exported variables like that, and this is how you can like end the group. So we need stuff like run speed damping, because you know, if you play the Mario is kind of sliding a little bit when you're changing the direction of the movement. Let's do export var speed, export var jump velocity, and this is going to be -340. Okay. And I believe this is it. We need the setting for the gravity, but I decided to remove it, but we can bring it back easily. So this is available via project settings. Get settings, and this is going to be physics 2D default gravity. Okay, and we should be able to start coding. Okay, so we'll handle the movement in the physics process because we're using the physics engine to move our player. So if first thing, if he is not on floor, then you can just say apply the gravity times delta. Okay, then we need to handle the jump. So let's do apply gravity here. Just a little bit of commands. And here is action just pressed. And if you take a look at the jumping in Mario, it's really interesting because if this is our player, he might jump in one of two ways. We could do the oops, not that one. We could do a short jump just by tapping the space, right? Or alternatively, if we hold press and hold the space, we should do a long jump, jump much higher, and we have to program it, right? Because you can just tap the space and do a small jump, or press and hold and do a bigger one. So let's try to handle this. Basically, it's rather easy. So if we are on the floor, we do the standard jump, which is jump velocity, yes, but then jump velocity. But then if we're in the air, right? Like if we are, so this is that case, right? This is the standard jump. But then if we are in the air above the ground and the player just release space, so he's no longer holding space, we should cut that height of the jump in half, basically. So we have to check right after we handle the standard jump whether the space was released. Jump velocity YY, too many Y's, okay? But then if input is action just released jump and velocity, so we are above the ground, velocity of y is less than 0, because if it's less than 0, that means this might be confusing, and it's often is, right? If we are in the air, right? If we are in the air, you might think, well, that means that the velocity of y is greater than 0, right? Because we are jumping. But this is not correct. Remember that the axis in the on the screen are like that. So this is your y. So we are looking for y, velocity of y being less than 0. Okay? Then I love paint. So here we'll just cut it in half. 0. Okay, let's try this. And we are stuck. Oh, of course, this is because we have to call move and slide. Okay, so now I am just tapping space, and now I'm pressing space and holding. Can you see the difference? So this is the simplest way how you can implement the variable height jump in Godot. Very simple, very nice. I love it. Okay, so here we have handle jumps. Perfect. Then next thing to do is to actually handle our movement. So let's handle handle axis movement. And this is rather simple because we can get the direction of the movement by just getting the axis between left and right. And we actually have to implement that sliding. Maybe let me show you. What I based the tutorial upon really was this implementation found here in the Super Mario game. So let's disable the sound, and I'm running here, and now you can see that bit of a slide because of the inertia when we're changing the velocity. This is really cool and gives a weight to the movement. It's wonderful, really. Okay, so we have to implement that. So let's start by saying if we have any direction, so it's not 0, then the velocity x, right, is equal to lerp, and this is just linear interpolation, meaning that the value will change gradually based on the weight. So velocity x, speed times direction, and then we get run speed damping times delta. Okay, but then we have to get this notion of slowing down, right? Because we don't come to stop like abruptly and immediately. So I can just say if there's no user input, because that's what this means, there's no user input because direction is 0, so there's no left or right. I'm going to say velocity x, just move toward, what should we move? From velocity x to 0 with a speed times delta. Okay, and let's see how this feels. I'm moving and I'm stopping after a while. Okay, this doesn't seem correct because we don't have any animations yet, but let's code those animations, and I'm going to try and keep it a little bit separate, just a little bit, because I don't want to shove all of my code into the main script. I try to keep it split. So actually, maybe we should handle this in the next section. Yeah, we will do that in the next section. So I'll see you there. Okay, let's add some life to our player by working on animations. And I'm going to add another script here to the animated sprite 2D, right? And going to scripts, how should we name it? I'm going to name it player animated sprite, but we'll do this snake case player animated sprite. Okay, and we will add a class here. Class name player animated sprite. Alrighty then. And what we need here is a function, and I will call this trigger animation, where we will pass velocity, which is going to be vector2, direction, which is int, and the player mode, which is player mode. First thing that we'll have to obtain is the was pass for now the name of the animation. And to do this, actually, let's configure our animations first. So let's do big idle. Come on. Oh, I have to create the new animation. Big idle. Then we also have like shooting idle. So this is going to be the the boring part where we create all of the animations. Okay. Then we need let's create big jump. Okay, then small jump and small jump. That's better. So small jump, Mario small jump. Okay, and then we have shooting jump. Okay, next thing is let's see, when we are sliding down the pole at the very end, but we can already prepare this. So small pole, big, come on, big pole and shooting pole. Oh, I should just change the name here. Shooting pole. Yeah, we should definitely define all of the animations already. Just not to worry about them later. Then we have sliding. So small slide, big slide, shooting slide. So we have big slide, small slide, shooting slide. Okay. Then we have depth. Should be rather simple. Then we have shoot. Which is going to be Mario shooting. And this is quite different because we will not loop. We will set the FPS to 10. Okay. Then we have running animations. So small small run. This is going to be 1, 2, 3. And let me check. This is 10 FPS actually. Then we have big run. Which is also 10. 1, 2, 3, and then shooting run. Shooting run 0, 1, 2. Also 10 FPS. And I believe that's... Oh no, we will also need 2 other animations, which is we have to play the animation when we are switching from small to big, and also from small to big, from big to shooting, and from small to shooting. Okay, so this is rather easy. Let's see, small to big, and we're gonna just use idle animations from that. So we'll do 5 FPS, no looping, and we'll just play this. Okay, then we have small to shooting. And I know this is not correct, because in the original game, it is that whenever you get a bonus, it will always be a mushroom that makes you big first, and then a flower that allows you to shoot. But I just changed it a little bit, because, as I said, this is not 100% precise recreation of the game. But I am hoping that you will be happy with this nevertheless. Okay, let's see, small to big, we should also add 1 more repetition to that, and then also big to shooting, so big. Okay, don't repeat. This one, and this one. Okay, and I believe we have everything right now that we need, and we can go back to coding. Okay, so I set it up, as you can see, with those prefixes: big, shooting, small, and the first part of the animation name is actually small, big, or shooting. So let's fetch that animation prefix. And this can be done by just saying player mode, keys, find the key that is actual player mode, and turn it to snake case. Okay, and then if not get parent is on floor, we should play animation. So this is %s jump, and then %s with animation prefix. Okay, and we should call it probably in our player. So here, if we have a direction, no, here let's just call animated sprite trigger. I would really like to get those autocomplete hints here. So this is player animated sprite. Trigger animation with the velocity, with the direction, and with the player mode. Oh, and we have to have the player mode defined here. So let's define this. Player mode is equal to player mode small at the very beginning, right? And then I can pass it here. And it should compile. And okay, it's stuck at the very beginning. Okay, this is probably due to the fact let's see, that we don't actually run anything else, but it will fix itself soon, because we will say that else if we have to handle the sliding. So if the velocity x is not equal to the sign of direction, which means basically if the current velocity has the different vector than current direction, and that might happen because remember that we are slowing down. So this is the ground and we were moving, oops, let's change the color. We were moving our player in that direction, but then we abruptly, oops, switched the direction, right? He still has some velocity because of the inertia that we coded it right here. So he still has some inertia here, but the direction is already switched. That means we are switching and slowing down. Therefore, we should play the slide animation, right? So this is the direction, right? But this is still this is the velocity, but this is the direction we just switched, right? And they have different vectors, meaning we should play the slide animation. So we have to check, of course, where the velocity is not equal to 0, just to be safe, and where the direction is not equal to 0. And then we should play %s slide with animation prefix. And be sure to set the scale to direction. Invite vector and int, because that's velocity x, of course. Okay, and then else, here we should handle the running animation and the idle animation. But first, so this is like, oops, handle slide animations. And here we have to handle the sprite direction. I'm trying to remember about adding those comments because they are really helpful. So here, if scale x is equal to 1, but the sign of velocity x is equals to -1, and if you don't know the sign function, it will just return -1 or 1 depending on the number. So for -5 it's going to return -1, for 23 it's going to return 1. Scale x is equal to -1, else if, so the other direction, and sign of velocity x is equal to 1, scale x is equal to 1. Okay, and then handle run and idle animations. It's always smart to keep those comments, right? Because when you go back to your code, you might just not remember what it's doing. %s run and animation prefix else play %s idle animation. What do you want from? Oh, yeah, buddy. We have to indent that. Animation prefix. Cool, perfect. Nothing like a good typo at the start of the day. Okay, let's see what we achieved. And we have something going here, right? This is pretty cool. And we have jumping. Maybe, just maybe, we're a little bit too slow. Let's go to player. Let's check the speed. Let's bump it up to 200. Yeah, this feels better. Okay, yeah, so we have our Mario jumping and sliding and moving. So the question is, what should we handle in the next section? And I'm thinking we should work on the enemies. Yeah, that should be good. So let's handle the enemies in the next section. So in our game, we'll have two types of enemies. Goombas, which are those mushrooms, and Koopas, which is like turtles. And they're quite different when it comes to what they can do. But for example, they move the same and they should react to a player in the same way. So how can we actually make it work? We will use inheritance and object in object-oriented programming. There are other ways. We could also use compositions, but what we'll have is a one base class that we'll call enemy. It's like basics of object-oriented programming, and then we'll have two different classes for Goomba and a different one for Koopa. And this should make you at least a little bit more familiar when it comes to inheritance in object-oriented programming in Godot. So let's do this. Okay. So we will not have any node actually that could have the enemy script attached because it's not concrete. It's just a base class. To do that, I'm going to go to script and create new script. Call this enemy GD. And let's see, what do we need here? We will base every enemy on the area 2D, so that's gonna be our extended class. And then I will just give it a class name of enemy. What should each enemy of our have? Well, we need horizontal speed. I would also like my enemy to be affected by gravity, so I will need vertical speed. And for now, I'm going to set it up very simply and say just move left, right? minus equals delta times horizontal speed. And right now I do not have any enemy node yet. So to do that, I'll create new scene, use area 2D, call this Goomba, and I will add animate sprite here. Let's go to sprites, new sprite animations, and we will add two things here: the walk, which is going to be 5 FPS looping and autoplay. And let's see, do I have Goomba walk 1 and Goomba walk 2? And then new animation for dead, which is Goomba flat. Perfect. And then going to 2D, let's switch to that. I can and I will add a collision shape, which is going to be rectangular. Okay, so this is my first enemy. I can save it in a scenes. And then the second enemy. So new scene, area 2D, and this is Koppa, if I remember that correctly. And it's pretty much the same, so let's add animate sprite 2D, animation, new sprite frames, and what do we need here? A walk and dead. So Koppa, default one, which is going to be the walk. Okay, 1 and 2, and then dead, which is going to be Koppa shell. Okay, change it here, and let's see how can we set this up. So we need a collision shape and rectangular, and I'm gonna set this to be 20 and 14, and you might ask why. This is because this area is enough to detect the collision with the player, and if I'm going to go to frames and switch it to dead, right, you will see that if I move it just a little bit down, it also encapsulates the dead sprite pretty nicely. So that should be enough for us. Let's switch it back here. The problem, of course, here is coding. So let's handle the Goomba first, and I'm going to add a script here. And here we have the enemy script, and I'm just going to extend the enemy. Okay, and let's see whether that works by going to main and saying instantiate scene here, Goomba, and he should start moving. Yes, but the problem is that he's not falling down yet. Sorry. But then if I decide to instantiate Koppa here, because he's extending the enemy and the movement of the enemy is already coded in the enemy script, they should both keep on walking. But as you can tell, there will be some differences when it comes to interaction with the player, of course, but we'll code that soon. So we have our enemies walking. Right now, let's add the gravity to our enemy. And this is actually rather simple, but we will have to add some nodes here. Let's move it out of the way. And let's actually group them because I intend to keep that tree in a rather readable state. So let's add empty node. Let's move it out. Let's call this enemies. Poop and poop. Okay. Then let's go to Goomba and to Koopa. And I am going to add a raycast 2D. And I will make it detect the ground and detect the obstacles. And I believe the target should be right at the bottom of the feet, so 0.8 here. And in case of our Koopa, I believe this will be a little bit different. So let's add this. It should be 0.12 to stay at the feet. Okay, and then I can just go to my, by the way, quick open shortcut is Control P. Enemy script, and I need to get a reference to the raycast here, but this is not a problem. I should be able to just drag and drop it, and it should be there because both of Koopa and Goomba will have a raycast, and I can then say if raycast 2D isn't colliding should be raycast 2D, yes, and then just position Y plus equals delta times vertical speed, and that should make our wonderful enemies fall down. And it should be also here if we set the proper collision masks. And it's not because we don't have a script here. Let's go to scripts. And all we need to do is just say extend the enemy. Perfect. Now they're being affected by the gravity. Cool. So that was the basic enemy setup. In the next one, what we should do is actually allow the player to jump on the enemies to kill them. Let's handle the collision between the player and the enemy. And there are a few things here that we have to handle. First thing, there will be some differences in what happens between the types of enemies, and also we have to write the code for our player to actually stomp on the enemy, because I hope that you all remember, don't save, that when we have an enemy that is just walking somewhere, we can kill it in two ways. We can shoot it with the fireball, but that's for later, or we can jump on it. And to register the jump properly, it has to happen on some range of angles, right? If you hit the enemy from here, the player is done, right? Because enemy got you. But if you stomp on it from above, right, then you kill the enemy. So we will have to code this. But let's start by actually going to enemy script and what should happen to each of the enemy types whenever he dies, right? This is not specific to Goomba or Koopa, but what should happen? Well, you should stop any movement here. So on die, we should stop the horizontal speed and stop the vertical speed. And also we need a reference to an animated sprite 2D. And we should just play die. Okay. So this is what should happen for each enemy. Now, to handle the stomping, let's first maybe let's first go to our player, because we will have to detect the collision here. So we should add the enemy as the collision mask, and then to handle the collision. This is going to be interesting. Let's see. We will do this by actually using the on area to the entered. So this part right here will not handle the enemy collision with the physics engine, but I'd rather use the area collision. So I'm going to go to node and check on area entered, and let's connect this to our player script here, and then we can start working. So first thing first, let's see whether this works. If area is enemy, let's print enemy. Okay, and let's see. Okay, yeah, we can detect the collision with the enemy. Perfect. So I'm going to just write a separate function here and call this handle enemy collision. And now that I'm thinking this could be split up and probably handled by a separate script here, right? Just to keep our contexts, our scripts separate. I could add another script here and handle that here, but this is fine. Our player controller is going to be just a little bit longer. Handle enemy collision with area, which is of type what do we need here? Area 2D. I'm gonna assume that's, or even we can be more precise. This is going to be enemy of type enemy, because we know we're colliding with the enemy. Okay. Let's check whether the enemy is null. It shouldn't be, but just to be safe. And then we have to check what should happen. So we need to get the angle of our collision between the player and the enemy. So angle of collision, this is rad to degrees, position, angle to point, enemy position. Okay, and it's going to return in radians, so we have to translate it into degrees. And then what we will define is the minimal and maximal degrees, right? As it's not here. So as I was showing you, right? There will be minimal and the maximal degree, and in that range we detect that we actually stomp the enemy and we're not dying. So if we got hit like from that angle by the enemy, that means the player is dead. So this is going to be from 35 to 135, but you can adjust that value as needed. So let's export another group actually. Let's say stomping enemies. And I'm going to say export var min stomp degree, which is 35. Export var max stomp degree 145. And then what happens when you stomp enemy, you get this like a little bit of bump, a little bit of auto jump by the player, so he can stomp 2 enemies in a row, for example. Stomp y velocity. Okay, and this all can be adjusted. We can see that we have all of this available in the inspector. Okay, so we have the angle of the collision. Let's see. And then I can just say if angle of collision is greater than mean stomp degree and max stomp degree is also bigger than the angle of the collision, we'll call enemy die. Okay, else, so enemy hit us, we will die. And for now I'm just gonna fill out that function, sprint die. Was it wrong? Die. Okay, small typo. Let's see. So I should die. Okay. And then trying this again. If I jump correctly, we have a debugger issue here. There is no animation with the name die in the enemy. Okay. Interesting. Let's check this dead. And here also dead, so I made a mistake here. Let's play dead. Okay, I'm trying to jump on you. Perfect. And also on you. Wonderful. So now we can stomp on our enemies, but this is not everything. Sorry, I always have a little bit of cough. So on enemy stomp, what should happen? Because we will have to write this. And this is going to be very simple function. Add this. Oh, let's call this. Well, we can call this on enemy stomped. And I will just say velocity y is equals stomp y velocity. That should give us this little bit of auto bump. So, let me jump on you. Boop. Okay, but yeah, you can see that now we're stuck on stomping. So it should be possible to stomp on Koopa again too, because if you remember the game, right? If you stomp on the turtle on the Koopa, right? If you stomp on it, it gets in its shell, but then if you stomp on it one more time, it should send the shell across the screen and also probably killing other enemies. So in case of our Goomba, we have to write a little bit of code. So when we call die, we should set collision layer value to false and collision mask value, sorry, to false, and also this to false. Is this correct? Yeah, because of course we have to set the collision layer mask to 1. This is correct. And then this is layer 3, so probably do that. Okay, and now watch what happens if I stomp on this guy. Right, nothing. He's not stopping. Why is that? This is because we're calling enemy die, and this call previously would trigger that script in the base enemy class, but right now it's being overridden by this function call. But what I would like to happen, let me just do that, is do what's in the base class, but also what I defined here in the very same function. And to do this, I can refer to the base class by using super keyword and also calling the code from there. So first, when that happens for the Goomba, we'll call that function, which is going to trigger the code from the enemy base class, and then some additional stuff. So let's try this again. Okay, and it's not working, probably because why? Oh, because we don't have proper collision here. Okay. Okay, so now as you can see, I'm not able to jump on Goomba again. So this is perfect. Okay. So yeah, these are the basics of the object-oriented programming in GDScript. You just create a base class that you know you can write for all of the enemies or all of the types that you would extend, and then also write a specific code here. Okay, so you have that done. Let's see what should happen for Koppa when we die. This is going to be a little bit more complex. So let's see. We will have to track whether he is in a shell or dead. Maybe let's call this in a shell. Okay. And then what we will do is on die, we'll check whether he is not in a shell, is in a shell. We'll call super, and then we need to start thinking about things and stuff. So this is going to be a little bit different because you can see that here there are some differences that we have to adjust for, right? So what we'll do is we will actually change the collision shapes. So this collision shape is matching pretty nicely when the Koppa is in a shell. So let's save this. Let's go to resources, and I'm going to name this Koppa shell collision shape. But then again, if we switch it up to walking koppa, I'm thinking we should probably set a different collision shape here. So let's create a new collision shape. And let's set this to be 2023. And I'm thinking... Okay, this is pretty much okay. 2022. Let's save this as a koppa full collision shape. And then in our code, I'm gonna get references to both. We will start with the koppa full. This is good. And I'm just gonna make sure that on the ready, let's get the reference to the collision shape itself. Collision shape is set to koppa full collision shape. Okay, because you can manipulate this property via code. And then I'm gonna do... We'll also need to change the position of the collision shape, right? Because if you go to 2D, if we go to sprite, change the sprite to dead, and even if I'm going to change this to koppa shell, you can see that it is not in the correct position. I would have to bring it down a notch. So let's also do this, and I believe this is like 5 pixels. So I can say koppa shell collision shape position is vector 05. Perfect. And then here I can just do collision shape is equal to koppa shell collision shape, and collision shape position is equal to koppa shell position. Okay, and then I can say that in a shell is true. See where this is working. Let's jump on it. And it is not working. Okay, let's take a look at our koppa. Collision, of course, is wrong. It should be enemy, and mask is 1. Try this again. Okay, but you can see I have a problem in a debugger here. Can't change this state while flashing queries. Use call deferred. Or set deferred. Okay, so something is ongoing there, maybe the change of animation or something else, but this is not a problem. We can just defer it to when we have enough processing power or resources available. You can just read this. Yeah, set deferred at the end of the current frame, right? So this is perfect because at the end of the current frame you're not busy changing frames, so you're basically free to do this. Let's see. And also here, set deferred position. That should fix the debugger error. Let's see. Yeah, I can still jump on it, but and to send it and collide with other enemies, I believe we can do this in the next section. Let's carry on with our interaction between player and enemies. So we have Goomba die. I believe there will be one thing missing here, which is we would like to present some kind of label, right? So let's see. We could go to player and we would like to spawn points label. To do that, I'm going to create new scene. It is going to be very simple. It would just be a label, and I will call this points label. And we will add a very simple script here. Let's go to scripts. And I will use tween to animate the label. And you will see me using tweens here a lot to do like the animations that can be created via code. So label tween, and we will apply just like every single time we do the tween, or every single time we spawn the label, we'll just give a player 100 points. This is like the simplest way I can imagine. Let's center it. Switch to 2D. Probably what I would like to do is use the proper font. So let's apply this. And for the font size, do we have anything specific here? Font size is 10. Okay. With this, we can just save this in our scenes, and let's fill this script. So get 3 and create tween, and I would like my label just to move up a little bit. So label tween, tween property of self, position vector 2, and we'll just bump it up a little bit, so it's going to be position plus vector 0 minus 10 and duration 0.4. And when you're done with this tween, just Q3. And this is not a function call, this is a function reference. Okay, so now I will need a reference to that in my player. So these are not inspector references, this is more like already, right? So let me think. Basically I just want that label here, and I'm going to call this points label scene. Perfect. And then when we kill the enemy, just spawn points label and pass enemy there. So let's write that function. Right. And this is going to be pretty simple because we will just do points label scene instantiate. We'll have to set the position. That's why we have the enemy here. -20, -20. Add a child to a tree. And we'll also create a signal to inform UI that the points were scored. So here I can just say identify area not defined because it's enemy, and here I can just say points scored emit, because we will use this later. So let's see. Bonk. Okay. Then the other thing for our Goomba is that he has to go. Like he has to disappear. So let me think, how can we approach this? We should queue free. The problem is when, right? Because he cannot stay here just forever. Can he? Okay, so we have to figure out a time when to get our Goomba out of the way. We could just create a timer, right? So get 3, create timer, and I'm gonna say like 1.5 seconds, and then timeout, connect, QE3, and pass a function, and we can create inline timer. This way we don't have to add the node. So let's see whether that helps. Yeah, perfect. Okay, we have that done. Now we have to write a code that will make the Goomba shell fly across the screen. And this actually is going to start in a player. Yes, so let me adjust the chair and let us code this. So here, whenever we collide, right? Let's check. If is instance of an enemy is koppa and enemy as koppa in, how did we call this again? In a shell. Okay, and then we'll just else everything else. Okay, and then if we do that, enemy as koppa, I'll just say, I don't know, on stomp, and we will pass player global position there. So now going to identifier koppa not declare in current scope. Why? Oh, we don't have a class in here. Okay, but I'll fix it. Okay, now it fixes itself. And we have to write this on stomp function, which is gonna send the shell flying across the screen. So Okay, that should be rather easy. Let me think. We're in a koppa and we want to write on stomp function. So we take player position, which is vector 2. First thing we have to handle is setting the correct layers and masks. So set collision collision mask value 1 false, set collision layer value 3 false, and now we move our koppa in a shell to a proper layer, which is koppa stomped, and then we just say movement direction is equal to 1 if player position x is less or equal global position x, else is -1. Because, let me show this to you, depending on which side of the shell we will stomp, it should go in either direction, right? If we stomp on the right, it should go to the left. If we stomp on the left, it should go to the right. And with this, I can say horizontal speed is equal to minus movement direction times slide speed. And we will just define the slide speed to use. Let's see. I'm going to say that slide speed is equal to 200. Let's see where that works. What is wrong? Varied operand news and float. Why is this? Because we're using beta version, and from time to time, yeah, you can see it like loses the references to the exported variables. So what I have to do is just restart Godot. Yeah, if it happens to just restart the Godot, but we've lost the variables here, but the default values should be in a code, so we have to unfortunately provide those here. 200 minus 350. This is a beta version of the engine, so sometimes it's, it just breaks. You have to live with it. Okay, should be all good right now. Okay, let's try stomping, and let's try stomping again. Perfect. One thing that should happen though, we should also get points for stomping. So that's one thing that should happen. Right, and the other thing that should happen is it should be possible to kill the Goombas with the shell of the koppas. So we have to also add this. So let's see. In the enemy, I'll write another function. I'm going to call this die from hit. So whenever you're getting hit by koppa shell or the fireball from Mario, we should do some things. So set collision layer disable the collisions. Set collision mask value. Rotation degrees, we will rotate upside down. Disable the vertical speed and horizontal speed, and create a twin to animate. So die twin is equal to get 3 create twin die twin property self position. So first go up a little bit. Point 2, and then after we're done with that, go down, right? This is how the animation goes, I believe. So to do that, we have to chain the twins. Twin property self position plus vector 2 0 500 4. Okay, and then we'll also spawn the points label. So we have to have a reference for that. Let's put it here. And this is points label scene. I always add this suffix. Points label scene instantiate points label position is equal to self position vector 2 minus 20 minus 20 and yeah, let's add this. Get 3 root add child points label. Okay, so we die from the hit if we're hit by koppa, so we can do, let's see, we can do probably I can just go to enemy because they should behave the same. So on area entered, if area is koppa and area as koppa in a shell and area as koppa the horizontal speed is not equal to 0, then I can just die from hit. Okay, let's see how this works. So I'm stomping on you and there's nothing, no collision here. Why is that? This is probably because you're interacting with a player as Goomba, but we should also interact with koppa stomped. And koppa should also interact with koppa stomped. Let's see this again. Now I'm pushing you and nothing happens. And this is probably because we are not connected to the signal on area entered. So let's go to Goomba, connect to on area entered, connect, and it should connect to that function and do the same for koppa. So connect. Let's see whether that is working. Perfect. Let's now test it for koppas. So let's duplicate them, put them at the back a little bit. Okay, and let's wrong direction. Let's try, and perfect. Okay, the one thing that we also have to add is the for both of our enemies is we should remove them from the memory of the game when they're outside of the screen. So let's find visible on screen notifier. Let's connect to screen exited, but we can just copy this into our enemy and we'll just Q3 and let's add one to koppa and let's connect to screen exited. This is correct. So I'm gonna run the game and we'll switch to the remote tree. Here we have our enemies. Let's try to get rid of them and let's see. And now they're removed because they're outside of the screen. Perfect. So we have that handled for the enemies. Next section will probably add the possibility for our player to die when he's small and he hits enemy. Okay, so the next step is for us to code the player dying, and this is going to be a rather simple. So in the player we have that die function which does not do anything right here, right now. But let's see. First, if player mode is player small, but then we'll also have to handle the case when he's in another mode but gets hit. So for now we'll just do big to small here. We will need the information about are we dead, because we don't want to collide. There might be a case when you're dead and during death animation, but then your death animation collides with the enemy, so we have to keep track of that. So I'm going to just do a simple flag here. So maybe here I'm gonna create a section, called it player state flags. So is dead, and it is false at the very beginning. So here I'm going to say is dead is equal to true, and this is going to be useful because somewhere here, yes, if we are dead, just don't handle the enemy collision at all. This is the first thing we have to do. Second, animated sprite 2D play death animation, but then disable the collisions. Set collision layer value 1 to false. Then we will also have to disable everything that is being done during the physics process, so all of the input processing and physics engine. Set physics process false. Then let's do the twin. There's some mixed use of spaces that should fix it. So def twin, and this is of course get tree, create twin. Question is, do we have something like a twin? No. Okay, so we have to do it via code. It'd be cool to have the node for this sometimes, but you know, it's fine. We are coders, we can code this. Self position, first go up. So position plus vector 0 minus 48.5 and then go down. So def twin chain, come on, twin property self position plus vector 2 0256, 1 second, and add a callback to it, twin callback, and we can do inline function here, like the anonymous function, get 3, reload current scene. Okay, so now if we get, did we lose all the references again? Oh, Godot is not liking me today. I have to restart the editor. And we are back, and that should allow us to die. But it happens too quick. So this is not correct. Let's see. We should go up and then we should go down. We change this. Position -48, 256, 1. It feels like it's not chaining properly. Let's see. Yeah, okay, there's an error in the booger. Mismatch between initial and final value, nil and vector 2. But why? Let's see, self, posi. Oh, there's a typo. Of course it is a typo. Okay, yeah, now it runs smoothly, but there was a problem here. Right, can you see it? I can stomp it. So let's see. When we die, we should disable set collision layer value 1 to false. This is correct, but also let's see. The collision probably mask, right? Let's see, set collision mask value 3 to false. Let's try this now. We're still stomping on you. Okay. This should not be happening, as you can imagine. Play dead, set physics process false, set collision layer value 1 to false. Oh, I think I know what is happening. Because in our player we handle collision via area, right? So we have area collision shape, but we also need to get the reference to the area itself. And then here in die, we're gonna go and say area to D, set collision layer value 1 will be false. That should solve that problem. No, it doesn't. Let's see. And then the mask. Set collision mask value 3 to false. Let's disable everything. Now it's working. Okay. So I'm gonna assume that this is not needed. Well, actually, this is needed. This is needed, but this one. That should still work. Right. Perfect. So we have our depth interaction there. Done. Okay, it's time for us to start working on the bricks and mystery boxes. And again, as with the enemy, I am going to start by creating a base class, right? Because what you get there is you have that brick, right? And it works two ways. If you're small as a Mario, it should move a little bit up when you bump it, and when you're a big Mario, it should like break into pieces and go away. And additionally, any enemy that is above, right, should be killed. And then on the completely other note, you have the mystery boxes that can contain a coin, a mushroom, or a flower, or basically any other bonus. So we'll handle the basic of the bricks right now, and then we'll do the mystery boxes, and also we have to do the there's a lot, like I'm gonna spend whole day recording it, but it's fine, we can manage. Okay, so let's create the base script for that, and I'm gonna call this block. And both the mystery box and the brick gonna extend static body 2D, which is a fine class to use when we would like to have some kind of static body, which means like a wall, an obstacle, or something like that. Okay, let's do class name block. That's it for now. We'll start by creating the concrete implementation of that class right now, and that's going to be static body 2D, and I'm going to name this brick. And the brick in itself is going to have a sprite. So let's go to 2D, sprite 2D, and this is going to be, let's find it, brick. Okay, and let's add the collision shape. This is going to be a simple rectangular collision shape. Perfect. And then we can start coding the concrete class. So let's add a brick. Let's go to scripts. Okay, dokie. We will extend the block. Okay. And we will need a few things here. So class name brick. Could not find base class block, because can you, is this saved? Okay, now save it. Brick, now it's all right. Okay, and we can go to our 2D and instantiate brick. Okay, so now let's get rid of our enemies for now. And let's see, it is moving. Oh, because I attached it to a player, which I shouldn't. Okay, so now you can see that I can go through it. This is the first problem, right? So let's go to our brick and let's set up the collision, and it should be an obstacle, and it should interact with enemy, player, and koppa stomped. And I am still able to go through it, This is because the player is not colliding with the obstacle. Or at least that's what I'm hoping for. We can still go through it. But why? Let's see, player. Oh, I didn't add it here. Okay, let's also check collision here. Now, yeah, now we're being stopped. But what actually should happen, it should be moved up a little bit. Okay? So, but then when you're big, it should be crushed. So go to our brick and we'll write a function, call this bump. We'll pass a player mode here, which is going to be player mode. And if player mode is player mode small, we'll actually write the code to move it up in the base class. So let's go to block, and here we can write our bump function. So let's think. Let me think. Do we need the player mode? Not really, no. So we can change that call and remove it. And then in a block, I can just say bump. And we will write a twin because I love twins. So get twin, create twin. We'll do bump, twin, and we'll twin property because that's the easiest thing to do in the world. We'll move it just tiny bit. 0.12, and then we will change it going back down. Also the same. So that should be it. Oh, the change should of course called, and after that between the property. Okay, let's see how that works. Function but not found in base block. The function signature, the function signature has to match. Okay, no worries. Player mode, even though we are not using it. Okay, what else you don't like? We need to pass it. The signatures of the function must match, so even if we don't use that argument, it has to be accepted in the base class. And it does absolutely nothing because we're not calling that function in a player, right? So this is actually going to be handled by, we can handle it with our physics movement. It could be okay also being done. How do I want to handle this? Because probably maybe I can handle this in the area. Let's see. On enemy stomp, on area entered. that should be on body entered in that case. All right, because it's a static body. Okay, let's see if body is block. It should work, but I'm experimenting here a little bit. Let's see. Actually, it doesn't, because we did not tell. Now we did tell to handle the obstacle. Interesting. Okay, oh well. Let's remove that connection. Disconnect, and let's handle not all, but disconnect. Okay. We can handle it here in our movement, because I can just say var collision equals get last slight collision, and if there is a collision, we can just say handle movement collision and pass the collision there. So let's see, function handle movement collision, and that's gonna be kinematic collision 2D. Yes. Okay, so let's see if collision get collider is block. Let's try this. Yeah, now it's working. Perfect. Okay, so we can do, we need to find the collision angle, because the bump only happens if you're underneath the collider. So this is radians to degrees, collision get angle, and if we're close to 180, I can just say collision get collider as block bump with player mode. And let's see where this is going to work. Yeah, now we are bumping our wonderful brick. Cool. Okay, and in the next section we should detect whether the enemy is on a brick and kill him if he is, and it should be rather easy. Okay, next step is to handle the enemy being on a brick and being bumped there. So let's go to set up, go to main. Now instantiate Goomba here. One thing though, I am going to change it a little bit. Let's move it out, as I'm going to disable his horizontal speed so that he just stays there. Okay, and then in our brick I'm going to add my favorite raycast 2D. The difference is going to be pointed to -10, Okay, so it's here and it should collide with the enemies. Perfect. And then I can just write some code in a block. So here, when we bump at the end, or maybe at the, it doesn't really matter, but here I'm going to check for enemy collision. This is going to be extremely simple. Check for enemy collision. Let's say, let's check whether our raycast, so we have to have the reference to raycast here. If raycast 2D is as raycast is colliding and raycast 2D, get rid of that, get collider is enemy. I'm gonna just say enemy is of course the raycast 2D get collider as enemy die from hit. Let's see where that works. So I'm here and I'm bumping you and it's not working. Why isn't it working? Let's see. This is all correct. This is the enemy. So the brick is here. It has a raycast. The block is here. Let's see whether this runs at all. Okay, it does. We have a raycast to D. So probably it's not colliding for some reason. Yes, it's not colliding, or the collider is not an enemy. And the problem is, if you go to your raycast 2D and check the collide with, by default it collides with bodies. But remember that our enemy is an area, okay? So I can just flip the switch here and our debugger is running. Perfect. So now we can bump our enemy. Let's just check it for the koppa instead. Put here and get rid of that. Oh, okay. Set the horizontal speed to 0 so that we can test it. And yeah, perfect. So we have that done. Now you can bump the enemies. In the next section we will handle the mystery box and we'll spam shrooms, coins or flowers depending on what's there. So I will see you in the next section. Let's handle the mystery box right now. So we will create a new scene. It's going to be a static body 2D. I am going to add animated sprite 2D. And let's go to animations, set up new frames. There are going to be two animations: default, which is going to run by itself, and then empty. Here we're gonna do empty block, and here for the default, where do we have it? We have mystery box 1, 2, 3. It doesn't really matter, or does it? Yeah, it does. So let's do it like this. This should be longer on the screen, so let's change frame duration to 10. And then here is 2 and 2. And 2, and you can see it down at the bottom here in the square brackets. Collision box. So collision shape. Same as for the brick. And we're here. Now, okay. Change it to mystery box. We will need raycast. 2D, again, -10. Collide with enemies, collide with areas. So the same setup as for the brick. Save the scene. And we can start coding. Okay, so we need to extend the block. And let's leave it at that and see whether everything works. So go to main, add the mystery box. So we should be able to collide with it. We should be able to bump it. Oh, and it feels like it's a little too low. And why is it falling down? Oh, because I parented it to koppa. Check your node tree every single time. Okay. Nice. The problem is, of course, we have to assign it to a proper mask, which is an obstacle. And I believe that, yeah, we also have to change this to be obstacle and collide with player, enemy, and koppa. Okay, and now, yeah, boy. Okay. So now it's time to start working on our bonuses. So let's get to coding. The class name is mystery box. Bonus type can be either coin, a shroom, or a flower. We will need the reference to animated sprite, and we will have the ability to set up the bonus type. We'll have the ability to turn it invisible, because from what I remember, there are invisible mystery boxes in the world. And we will also have a flag to track whether it's empty. Okay. So we have that. Then the simplest thing, if we decide that the box should be invisible at the start, we will trigger the visibility of the sprite, because we're still able to collide with that. Okay. Then we have to handle the bump here, because it behaves different than a brick. If it is empty, just don't do anything, just return. If it was invisible, now it should be visible, so I made sprite 2D, visible is equal to true, invisible is equal to not invisible. And then we call super bump, which requires player mode, as you remember. So we also pass a player mode here as a player mode. And then after that, we will make it empty. is empty is equal to true. Animated sprite to D play empty. And then all what is left for us to do, okay, is to spawn the bonuses. But first let's test whether we still kill the enemy by bumping. Perfect. Everything still works. So let me think. Here, based on the bonus type, we will no, bonus type, if it's coin, we'll spawn a coin. If it's Shroom, we'll spawn the Shroom. And if it's a flower, we will spawn flower. Okay, and we don't have those functions yet, so let's define these. So for now, just print stuff here. Okay. So we're starting as a base type with a coin, so it should trigger the coin. Okay, so we have that, and our job in the next section is to actually make the coin work, and then shroom, and then a flower. Oh, this is going to be a long one. Yep. Okay. I'll see you in the next section. Okay, let's handle the coin bonus. To do that, we'll need a new scene, and I believe that all that we need is only an animated sprite. Yeah, okay, so other node, animated sprite. Let's call this a coin. We need only one animation here. Let's find these. It should be coin something, right? So this is coin, or maybe, yeah, this is going to be coin 1, coin 2, coin 3, coin 4, played by default with 10 FPS. And then we'll need a very simple script here for our coin. So this is only on ready. We'll do a simple tween to animate the coin going up and down. We could also do it. We could also do it all in the animation player, but I love tweens. Coin tween. Get tree. Create tween. Coin tween. Tween property. Self. Position. Position plus vector. It doesn't really matter, but let's just go up by 30 and 0.3, and then let's go down, so chain it. Tween property, self, position point 3 coin twin callback QE3. Okay. And now I would love to save that scene as a coin. Then in mystery box, I need a reference to it. So this is going to be like bonus references. We have the coin scene. Okay. And then we need to spawn it in a spawn coin. So coin is equal to coin scene instantiate a coin global position is equal to mystery box global position plus move it up a little bit, so 0 minus 16, and get 3 root at child coin. That's almost all, because we will also have to update our UI, which we did not code as of yet, to display the correct amount of coins collected. But for now, what I'm going to do is I'm going just to add an empty node here. I'm going to call this level manager. And I'm going to add this to a group, and groups are like tags from Unity, mostly. Level manager, add this to a group. And I'm going to add a very simple script here. We saved that script in scenes instead of scripts. My bad. I will try to remember to fix this. Level manager. And here I am going to write a function called this. Let's first start by a new class name. And then I'm going to say on coin collected. Now just for now print coin collected. Nothing special here, but then in a mystery box, I can just say get 3 first node in a group, level manager on coin collected. And let's see how this works. Okay, let's maybe move the koppa out of there. Coin collected. Perfect. I'm a little bit sad that I did not decide to add the sounds to the game, but it would extend the tutorial and make it even longer. But I kind of missed this very, very special classical ding when you collect the coin in Mario. But it is all working. So the next step for us is to create a shroom that's gonna make us grow bigger, and we'll do that in the next section. The next thing that I wanted to add as a bonus is the shroom. So let's create a scene for that. We will use area 2D. Let's name it Shroom. Save it. Other stuff that we need here is of course the sprite. And we are going to use 1-up shroom, or maybe magic shroom. It doesn't really matter. It's the magic shroom, right? I know that in the original game there are different types of shrooms, but again, we're not making a complete game here. we will need the collision shape for here, for that one. So let's do it. And I'm going to make it like that. Remember to set the collisions properly. So I believe that this is a bonus. And it should collide with player. And also, since the shroom can move horizontally, it can fall down from the platform or from the mystery box that to spawn from. So we will need collision. No, we need shapecast. That's how it's called. Okay. It should collide with ground and it should collide with obstacle. It should collide with areas and bodies. And we need a shape for that. So let me see, it should be 12 by 16. Why does it look so strange? It feels like a bug. Let's see, this is the collision shape. Oh, okay. this is cool, but target position and oh, interesting. Yeah, we'll just need 0 0 for that. Okay, now we can start coding. Change it to scripts. Extends area to D. This is correct. And we'll need some definitions here. So we need horizontal speed. We can also do different way of gravity. Our enemies are falling steadily down, but here we can make it, I believe we can make it get more velocity as we're falling down. This could be interesting. So max vertical speed 120. Export var vertical velocity gain 0.1, and we also need reference to shapecast. Also, we will need a flag to trigger the horizontal movement and current vertical speed. Okay, and we need that flag because when you have that mystery box, right, and you spawn the shroom, it first like grows up from the mystery box and then only starts moving, right? So we'll disable the horizontal movement at the very start until the spawn twin or spawn animation is done. So when ready, we'll just trigger the spawn movement, another twin. Twin property, self, position plus vector to 0 minus 16.4, spawn twin callback function, allow horizontal movement to true. And when we have that set up, so let's see actually whether this works. So first we have to go to mystery box and then spawn shroom. It's going to be rather easy when we get the reference to the shroom. Okay, so var shroom, it should be shroom scene just to keep the name consistent. Shroom scene instantiate Shroom global position is equal to global position get 3 root at child Shroom. Okay, and it's gonna almost work, as you will see. So if I click on this mystery box, I can switch the bonus type to be Shroom, and then yeah, but can you see the animation? It is, take a look at it, the Shroom's gonna be in front of the box, which is not what I wanted. So what I'm going to do for my Shroom, or for the mystery box, I'm gonna make sure that the mystery box is rendered in front of other stuff, right? So I'm going to say mystery box ordering, I'm gonna say like 2, and then yeah, now the Shroom is being rendered behind the box at the very start. Perfect. And then I can make it move. So okay, if a function process with delta, if allow horizontal movement position x plus equals delta times horizontal movement, okay, so it should work already. But then for the falling down, if shapecast is colliding and allow horizontal movement, so we are actually moving, vertical speed lerp f, vertical speed, max vertical speed, vertical velocity gain, and position y plus equals delta times vertical speed. Else, set the vertical speed to be 0. Let's see whether it works as expected. Yes and yes. Okay, I can see that it's a little bit too high for my liking. So let's see the shapecast. Yeah, the shapecast is too big. So let's change the size of it. I believe it should be 18 by 18. Let's try this again. Yeah, 18 by 18. And now we have our wonderful Shroom. All right, perfect. The next thing is going to be handling the collision between player and a Shroom and making the player bigger. Okay, the Shroom collision. This should be rather doable. So let's go to player, and in our player we are already checking for some collisions, right? Here. Okay, then I can just check. Remember that our Shroom is an area. Handle Shroom collision, and let's pass this area there, and we have to write it. Handle movement, handle enemy, we can put it below. So handle Shroom collision, area of node to D is good enough for me. And if player mode equals player mode small, we have to become big again. So let me think how this should work. We have to disable the physics process because we'll have ongoing animation there. And then we can call animated sprite 2D play small to big. That should be the first thing that happens. So let's see where that works. And we're not colliding with the Shroom. Okay, so let's see. Let's see the mask here. We should be able to collide with Kumpa Stomped and also with bonus, because our Shroom is of bonus type when it comes to collision. Still nothing. And the Shroom itself. Let's see. The Shroom itself is a bonus, right? And it should collide with a player. So that should be the other way around. Okay, yeah. Okay, so this is done, but we have some problems there. Okay, let's see. First thing that we should do is probably in our player getting rid of that Shroom, right? So on area enter 2D, area query free. Then we should be able to change the behavior of our player when we finish that small to big animation. And to handle that, actually, I am going to go to animated sprite 2D, and we'll attach here to that script. We can collapse that, and we will attach to the script, to the signal that we need, which is on animation sprite 2D finished. Be sure to click on animated sprite to connect there. Okay. And then also we'll need to work on the offset of the sprite, but this is all fine. Okay, let's see. If our animation is equal small to big, let's see whether that triggers correctly. Yes, okay. So we have some work to do here. First thing, I will reset the player draw pair piece, and that's going to be a separate function. Okay. So I'm going to I'm going to set the offset vector to 0. And I'm going to reset some stuff in the parent. So we'll re-enable physics process. And we will re-enable collision value layer. Okay, and we have that done. Then let's see. We'll also use that small to, because there's also a possibility of the user going from big to small, I believe. And you can just run the animation in the other direction. So what we will do here is we will match get parent player mode. If this player mode big, we'll do get parent player mode is equal to player mode small. And the other way, if we're going from small to big, we will say player mode small, change it to get parent player mode player mode player mode player mode big. Okay, so this should happen on animation finished. Oh, what else do we have to do? Let's go back to our player. We will have to set the collision shapes properly, because let's go to our resources. What we have here is small Mario collision shape, which is fine, but we have to add another one when the Mario is big, okay, because that collision shape isn't gonna do well. So let's see. We create new rectangle collision shape, and it's gonna be 16 by 42, and I'm going to save it as the resource collision shape. Let's say that should be big Mario collision shape. Okay, and let's turn it back to small here. Small, and we need a function to switch those collision shapes. So what do we have here? We need the references to those collision shapes, and then big Mario collision shape. And I'm going to collapse that, and I'm going to write set collision shapes, and I'm gonna give it an argument is small, and we'll decide on the collision shape. Small Mario collision shape if player mode is equal to, let me check that. Oh, of course, is small, else player big collision shape. I mean big Mario collision shape. Perfect. And then I can just say this is a collision shape. And do we have the references for area and for body? Okay, so area collision shape set the third shape collision shape, and body collision shape set the third shape collision shape. Okay. This is all done. So then here I can just say set collision shapes to big. And this is correct. Let's see how this runs. I think we're still missing a thing or two, because this is all good, but as you can tell, the problem is we are getting into the ground as we're animating. Right after it's done, it works all nice, right? The problem is that we have the wrong offset during the animation. And the question is, can we somehow fix it? And we might try. I'm not sure whether we will be able to succeed. But going to animated sprite, we have on animation finished, but there's another signal here. And I believe this is called frame changed. So let's try to connect to it. And where it is on animated sprite to the frame change, and I connected it to the wrong place because it should be disconnect all. It should be in the animated sprite. So let's connect again, select animated sprite. Now we are in on frame changed. Okay, let's try and figure out whether we can set up the proper offset. So if animation is small to big, or animation is small to shooting, because that also can happen. Player mode is get parent player mode, and we will have to count the frames because there's a different option for the odd number of frames and even number of frames. So frame count starts as 0, and when we reset the player properties, we set the frame count to also be 0. Okay, and then we can start counting stuff. Frame count plus equals 1, and then if frame count modulo 2 is equal to 1, we will set the offset to be vector 2, 0, and 0 if player mode is equal to player mode big, else minus 8, and then else offset is equal to vector 2, 0, and 8 if player mode is equal to player mode big, else 0. Okay, and let's see where that fixes the problem with us getting into the ground. Yeah, buddy. Okay, so that should fix this. So we are handling the player going from small to big. What about the player going from big to small? And to do that, we will have to go into the die function. Okay, so let's find it here. Die function. By the way, here you have all of your functions listed for quick navigation. And here we have big to small. So let's try to write it. Big to small. Okay. So let's write it down. Set collision layer value to 1 and false. Set physics process to false. The animation name we should use, it is small to, is it small to big? Oh yes, it is small to big. If, and you can, well, it's called to big to small. You can ask, why are we using small to big? Watch and observe. Player mode is big, else it's small to shooting. And what we can do is we can play the animation backwards, right? by using the animation name here, then 1.0, and then the last parameter here is play from end. And we will say, yes, please. Play from end. And since we're going to be small, then we should reset the collision shapes with a small setting. So let's try this. I should go big. And I should be small now. Now I'm dying instantly because I should probably add invincibility frames. But we'll do that later, or maybe you can do it on your own. But that's how we can play the animations back and forth. So we can go from big to small and from small to big. Okay. Yeah, the next section should be us adding the flower and the shooting. Let's do that. So the next bonus that I would like to implement is the flower. And it's not going to be anything special. But we need to add this nevertheless. So new scene, other node, area 2D, shooting flower. We need a sprite. Let's find the flower here. It's there, and add a collision shape. Rectangular is fine. Boop and boop and okay, let's save this. Going to be scenes, shooting flower, and we need a little bit of a scripting here. So class name, shooting flower, that's the name, and a small animating twin. So var spawn twin. Basically, can I copy it from the Shroom? Yeah, buddy, and we don't need a callback here. Okay. Go back to mystery box, add a reference to that, and then spawn flower. Var flower is equal to, we need to name it as a scene, just so that everything is clear. Instantiate flower global position is equal to global position get 3 root a child flower. Okay, and that should work. So let's test it by going to main, selecting that mystery box and changing it to flower. See, and it looks like it is working. Can we jump there? Okay, it seems that I placed it a little bit too high. Not to worry. What I'm going to do actually is on our main, I'm gonna enable snapping, and that should help a little bit when it comes to moving stuff around. Okay, let's try now. Okay, and now we have to handle the collision. So for the shooting flower, the collision should be 6 and 1 because it's a bonus. And then in player, I believe in player, yes, we have to handle the collision there. So that's gonna be, we have handle enemy, we have handle shroom, and here we just check if area is shooting flower, handle flower collision, pass the area, and then area QE free. Or we don't need to pass the area actually. So let's find handle shroom collision, and here I will add handle flower collision. Physics process false. Find the animation name, which is going to be small to shooting if player mode is equal player mode small, else big to shooting. Animated sprite to D, play animation name, and then set collision shapes to be big. All right. Let's check whether that works. Oh yeah. Oh, and it's looping. Okay. Go to animated sprites, and that should be one of the shooting. Small to shooting is looping, but it shouldn't be. Okay, but it does not trigger the properties back, so go back here. So we are in animated sprite 2D, and we should be looking at small to shooting and big to shooting. So if animation is equal to small to shooting, or animation is equal big to shooting, we should reset the player properties, and we should go and get parent and set the player mode to be player mode shooting. Let's check this again. Okay, yeah, perfect. The obvious thing that is missing is we're not shooting yet, but we will handle this in the next section. All right, let's try and handle the shooting mechanics. And I've been recording for 6 hours now, and I'm getting pretty tired, but let's push through. So let's start by going to a player. And first thing we need to do is to check for the input action. So here, if input is action just pressed, shoot, and player mode to player mode shooting, just shoot. Else, handle the animation. And we don't have that function yet, but we can write it. Okay, shoot. So we'll just play the shoot sprite, and during that time we will disable the physics process, so you cannot move and shoot. It's not working like that. And then here in animated sprite, I believe we should also could not parse the global class player. Why? 67. Oh, okay. Oh, okay. So then here it will pick itself, and then if animation is equal to shoot, we'll re-enable the movement, get parent set physics process through. Okay, let's see where that works. And we lost probably the setup again. Right, let me restart Godot for the third time. And we're back. So now if I collide with a flower and change the mode to shooting, I should be able to, yeah, play the animation. The problem is it feels like it's looping. Let's see, player shoot. Is it? It's not. Okay. Let's. Oh, shot, shoot. Yeah. Here's the difference. Okay, now it works. Perfect. Okay, so the next thing to do is to actually create and spawn the fireball. So let's see. We'll need some stuff here. Let's do new scene. Other node area 2D as per usual. Call this fireball. Save in scenes. And we can set everything up. So what we will need is animated sprite 2D. And let's do new sprite frames. And this is going to be rather easy because we have a default loop, autoplay, and then if we go to our sprites, we just get fireball 1, 2, 3, 4. Perfect. So we have that set up. Then we will need to add a collision shape. Let's make it fit what we see on the screen. And then we will need a raycast 2D. That should actually collide with bodies, and it should be 0 and 5. And 2 and 5. So it collides with ground and collides with obstacle. Perfect. And then we can code our fireball. So change it to scripts. Okay. Let's get to coding. So we need a class name. And then we need onReady. Basically, we can just drag and drop, because why not? We will need horizontal speed. And we will need vertical speed. We'll need amplitude. And I'm going to set this to 20. We'll need a flag to know whether the fireball is moving up, because remember, boys and girls, that our fireball is moving like this, right? So it's, or even like this, right? So it's constantly moving up and down. So is moving up. We'll need the direction. which can be set to null. And we need vertical movement start position. Okay. All right. Oh, okay. I will definitely need to stretch after these hours of recording and programming. So default movement is very simple. Delta time horizontal speed times direction. Okay. And let's see whether we can spawn it already. So going back to a player, to shoot function. Let's see, we will need the reference of fireball scene. So let's get this. And then let's say fireball is equal to fireball scene instantiate. Fireball direction is equal to sign of animated sprite to the scale X. And fireball global position should be equal to something we add here. Let's see, this is the hand is somewhere around here. So let's add a marker to D. Let's call this shooting point. And let's drag this at the base of the hand. Let's grab a reference to that. So I can say shooting point, global position, get tree, root at tiled fireball. Okay. 71 could not resolve trigger animation. Why? You should be able to. Okay, let's see where that works. Velocity X, speed and delta. Did it crash again? Yes, of course. Okay, I think I know when those values are crashing. It is when I'm editing and when the game is running. So I must try to remember not to do this. Okay, so now we are shooting, but you can see that this is only going in a straight line. So let's fix this by going to fireball. And let's code the rest of the movement. So if raycast D is colliding, then set is moving up to true and set the vertical movement start position to a current position. Then if is moving up, position Y, if you decrease this by vertical speed times delta, and if vertical movement start position Y minus amplitude is greater or equal than position Y, we should say is moving up false. And then if it is not moving up, position Y plus equals delta times vertical speed. Yeah, and we need a call here. Let's test this again. Nice. You can see it is also working when we're on the height, right? And also from the ground. Perfect. Now to handle all of the collisions, we need to connect to area entered, and also I believe body entered. So here we'll just call Q3, and here we'll call QE3. But if area is enemy, die from hit. So let's see. That should pretty much be as done with the fireball. Oh, and the problem is we're colliding with ourselves, right? So the fireball, yeah, the collision layer is wrong for the fireball. It definitely should be different. So it is like 7 and then 3, 4, 5, 6. Okay, so these are the proper values for the collision of fireball so that it won't collide with the player. Okay, yeah. Okay, and then if we collide with the platform, okay, it doesn't bounce back, right? And I'm gonna say this is fine. To be honest, you should be detecting the angle of the collision, right? Or you can just disable that, right? But to make it work like in a game, if it hits the side of the platform, it should be destroyed, and then if it hits from the top, right, then it should not bounce back. But okay, I'm gonna say let's leave it as that. Perfect. The next section is, since now we can grow big, we should be able to destroy the brick. Let's do that. Okay, how to break the bricks when you're big. Let's go to brick, and here in else if we will start by, we need to create a particle system. Basically that's what we need. So GPU particles 2D, and as a texture we'll use brick texture. What else do we need? The amount is 4. There's no sub-emitter. Lifetime randomness, no. We need new process material. So particle process material, and we need to set everything up. So let's see, particles. This is fine. Spawn position 0, 0, 0, 1, 1, 1. Emission shape is going to be box. The angle is going to go from minus 180 to 180, and I am definitely not experienced when it comes to GPU particles. This is a very complex subject. Velocity, let's see, spread is 180. Velocity is from 10 to 12. Do you need anything else here? No, I don't think so. The time, let's see, one shot 1 second. Spread scale set to 2. Interpolate, blah blah blah, all good. Visibility drawing, visibility rect, all good. Okay, so let's see how this looks like. So if I'm going to press anything, yeah, you can see it's a little bit too much. It should be definitely smaller. Let's see, how can we make it smaller? There should be a setting for that. Okay, we should also set the direction here to 5. And I'm looking for something like scale. So display scale, and let's make it 0.25 and 0.25. And now it looks kind of okay. Let's see if there's anything else. Initial velocity, scale curve. I'm gonna say that looks good enough. If you want to make it better, just play with it. So now going to our code, I can say get the reference to the particles and get the reference to a sprite and say else if we are not emitting right now, set collision layer value 5 to false, GPU particles to the emitting set to true, sprite to D visible is equal to false, and also super check for enemy collision. And let's click on this, go to node, and when we are finished, just give it free. So our aim right now is to test this, and we will test this by putting the koppa right here. Okay, then we should be big or shooting, and then I should be able to just crash it and kill the koppa. Okay, that was like almost good. Let's find this brick. Sprite visible, false, of course. Let's test this again. Okay, now it's perfect. So now we can crash the bricks as a big Mario. Okay, let's tackle the next problem that we have in our game, which is we can just run off the screen. So we have to work on the player and camera cooperation here. So let's go to a player script and add another export group. And I'm going to call this camera sync. And let's close the export group. And I will call this export camera sync, camera to D, export should camera sync, and we will default it to true. Okay, and then let's see what we have to do with it. We will handle the synchronization in a process function. So let's close this. Okay, if global position X is greater than camera sync, global position X and camera should sync, then camera sync global position X is equal to global position X. Okay, and that should be almost enough. but we don't have the reference. So here we have the camera sync, and it should sync. We just need the reference to camera to D. Let's drag and drop it. Okay, and yeah, it should move along. The problem is, in the original game, once you go past given point, you cannot go back, right? So for example, I shouldn't be able to go back. Somewhere around here, I should be stopped, right? I cannot leave the left side of the camera. So we also have to code that one. So go to physics process, and I'm gonna find the left bound of the camera position, and this is camera sync global position x minus camera sync get viewport rect size x divided by 2 divided by camera sync zoom x. All right. Okay, so this is rather long line, but we're taking the global position x and we're trying to because it's centered, we have to subtract the half of the camera size, but we also need to take the zoom that we set up into account. Okay, and then below the stuff when we're handling the jumping or gravity, sorry, if global position x is less than camera left bound plus, I don't know, 8, and we're moving left, so just check the velocity sign here, reset the velocity, and return. So let's see how that works. I am moving, and now if I'm trying to leave that side, I cannot. Perfect. Okay, and I'm still falling down, but I cannot leave this part, which is great. So that's gonna be our basic camera setup done. Okay, next thing that we need to handle is actually the pipes. So let's start by creating new scene. Other note, we'll use static body for that, and we'll add 2 sprites here. First we'll name pipe top sprite, and the next one we will call pipe body sprite, and we will add a collision shape, but let's start with the sprites. So we need pipe top and pipe body. Okay, and let's see, the position of the pipe body should be 16. Okay, let's call this pipe. Let's save it in scenes, and let's see, we will need to go to pipe body sprite and enable the region. Enabled, and by default we'll set this to 32 by 16, so it's present like the same. No, collision shape, we needed 2, and we will use rectangle collision shape. We can change its color so it's more visible. Let's disable snapping, bring it here and here and here. And the problem is that we have the pipes. In Mario, we have pipes of a variable height. So I would like to create a system, a node where we can just set up height and it will set it up correctly by manipulating the collision shape and the pipe body sprite region. And this can be done rather easily. So let's add a script. Okay, and we will need some stuff here. So class name pipe. We'll set the top pipe height to be 16 and we'll export few properties here. Some of the pipes are traversable, meaning they will take you somewhere, right? For example, in our case, we will have one pipe that will take us underground. So traversable, is this a word? I hope so. Then we need references to collision shape and we'll need pipe body sprite. And let's call this dynamic region and position and shape. So we need a region rect and it's going to be rect2 and we'll instantiate it with a pipe body sprite region rect. We need to calculate its size and we know that for the horizontal size it's always 62 and then for the vertical height size, sorry, is height minus top pipe height. We have to include this. Then I can assign the region rect to the new region rect and I have to adjust the pipe body sprite position, which is going to be 0 and height divided by 2. So this is the adjustment of the sprite region, but we also have to adjust the collision shape. So that's going to be a new shape. We can create one from the code. We can set the size to be vector2, 32 for the horizontal and height for the vertical. Set the shape to be shape and collision shape to the position is equal to vector2, 0, height divided by 2 minus top pipe height divided by 2. Okay, let's set the collision properly. So this is 5 and 1 free for the mask. And yeah, let's see whether that works. So add instantiate scene here, pipe, let's do it like this, and then duplicate the pipe and don't make those children of the area. Let's set this to 64. Okay, yeah, we can see it's working. We just need to bring this a little back higher. And yeah, we're good, right? So now we have pipes, but they're not traversable yet. So in the next section, we'll work on the underground level, on the pipes being traversable. Yep. And slowly but surely, we are closing to the end of the tutorial. There's still some things to do, but we'll handle all of this before we're done. I promise you that. Let's handle the collision and the ability to go like underground and traverse the sewer system. So first I'm going to start by marking this second pipe as traversable, and then in player script, what do we have here? We should be able to handle movement collision. Okay, perfect. So let's check where we are colliding with a pipe. If collision get collider is pipe, we'll get the collision angle. Let's give ourselves a little bit more space here. And then if the collision angle is equal to 0, so we're on top of the collision, and input is action just press down, and there will be another check here, because when we have a pipe and we are as a player sitting on the edge of the pipe and we're pressing down, nothing should happen. We should only go down when we're like near the center, and then in that case we should go down. So we also have to check whether we are near the center of the pipe. Okay, so there's gonna be another end here, and this is absolute F collision. Collision get collider position X minus position X is less than pipe enter threshold, which I set to be a value of 10, I believe. Pipe enter how do you write it? Threshold? Okay. I believe that's it. And then also we need to check, this is a very long line, collision get collider is traversable. Okay, then we can go down the pipe. Okay, let's see whether this works. So here I shouldn't be able to go down because it's not marked as traversable, but here I should be. But if let me just clear that real quick. If I'm near the edge of the pipe, you can see that it is not working. Only here in the middle. Perfect. So here I can just write handle pipe collision, and let's write that function down. So function handle pipe collision. We'll do a few things here. Disable the movement. We will do the pipe twin, so the twin that will run as we enter. So again, get 3. Did I tell you that I love twins? Because they're so useful. Self position position plus vector 2 042.1, and then we will have to do two things after we're done, but let's check whether the animation is working. Yeah, it is. Perfect. We will need to actually pass some data between twins and switch the between the scenes, and also switch the scenes. So let's start by saying pipe twin, twin callback, switch to underground. And this is going to be rather simple. Because we'll say get. First, let's create that new scene. And I'm just also going to create empty node, call this main, and save this as underground. And I'm going just to I don't know, let's start by adding the color rect here, and let's make it black just to make sure that we switch scenes. Okay, we'll work off of that. So it's not going to work yet because let's pause it. Get 3, I change scene to file, and I need to find, could you help me a little bit here? In theory, I should be able to do this. Okay. So let's see, and I'm pressing this, and yeah, we switch scenes. Hooray! But to make everything work smoothly, I need to transfer some data between scenes, and to do that, I'm going to go to project settings, auto load, and I'm going to create new node, call this scene data. Let's add this, let's put it in scripts. Okay. There's not a lot that we have to store there, but there's some data. First going to be return point that we will use. I believe this is going to be vector 2. This is the information about how should we return from underground to the main level. And then we have to store current player mode. Okay, and then in main, in the player, when I'm switching to underground, I can say scene data player mode is equal to player mode. Mode. Okay, cool. That should be enough for us to switch to underground. And in the next section, we will handle the whole underground scene and probably traversing back to the main scene. Okay, let's handle the underground level right now. So let's open underground, switch to 2D. I'm going to start by adding camera, or basically I'm going to be smart and I'm going to copy the camera from the main. So it has all of the settings that we need. Let's place that color rect, and let's just scale it. I'm thinking yes. So let's just scale it. Okay. It doesn't really matter, but fine. Let's also copy the tilemap from the main. Pass it here, but we will change it a little bit. So let's clear everything. Whoa. Let's clear basically everything that we have in here. Let's check whether we have a physics painted here for the underground block and underground brick. And let's start painting. I hope I can get this right. So let's select the base style, and we should probably set this here from the top to the almost to the bottom. Then we have like free space here. Let's set the let's set the bottom here like that. Okay, I believe we should actually move it down like that. Move it down. Add a bit of stuff here. Okay, and then we have 1, 2, 3 blocks, and then this should be like 4. I'm thinking 4. Going like through here. Okay, and of course we need a player. So instantiate player here. Drop it there. You have all of the default values, but you need the camera, and we're not syncing camera in that level. So let's disable camera sync. Then I can just run that scene by clicking F6 or run current scene. And this is a little bit too high. So let's go back to the tilemap and get rid of that. Oh, wrong scene. Oh, did I remove the tilemap from the main? What? When did that happen? Excuse me? No tile set? This feels like a bug. But let's handle this. This and this, right? Ground block, tile set, paint. Yep. Okay, and now we're back. I'm not sure whether I understand what happened, but that's okay. Can I just select this and then paint it back? Remove all of this, paint this. Okay, now I'm hoping this is still okay. Good. Scene data is not declared in current scope. Okay, let's not worry about this yet. Underground scene, run the scene. Scene data is not declared in the current scope. Oh, okay, let's stop everything. And this is interesting. Okay. How about now? Okay. I don't know what exactly happened there, but we have that set up. And what we need actually is that pipe connector and the pipe. So let's start by adding the pipe connector. So the pipe connector itself is going to be static body 2D. Okay, and we need to add a sprite there, and that's going to be pipe connection connector or whatever, but that's what we wanted. Then what we need is a collision polygon for that. So let's try and add the points that we wanted here. So this, 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 and this, and I'm going to just adjust it. This is, I think this is good enough. Okay, this is looking good enough. But we'll also need an entrance here, and that's going to be area 2D and collision shape for that. Right, so that's going to be rectangular shape. We'll make it very small, and we will place it right here. I'm going to call this entrance, and I'm going to call this pipe connector. So now let's connect to the signal, and our player is a body, so we need body entered. Oh, we don't have a script yet. Scripts added here. So yeah, pipe connector. Okay. Let's do class name pipe connector. And now we can connect the signal body entered here on entrance body entered. Perfect. And what we'll need here is the information about return point, which is going to be vector2. We will set the return point to be return point and body as player. We will call this handle pipe connector entrance collision. Woo! That was a long one. So let's test it out by going to player and implementing that function. And for now, we'll just print something. Let's run current scene. Is it not saved? Okay, let's save it. Non-existent. Wait, what? Oh, I wanted to run the underground. Sorry. So we're not placing this yet. So let's instantiate scene here. Find the pipe connector. Place it like right here. Okay. And run the current scene. I mean, not the current scene, on the underground. Non-existent handle pipe in base Neo. But that should not trigger. Oh, I know what might be happening. Of course. So we need to open the pipe connector and set the proper collisions, of course. So for entrance, this is actually 1 and 1, but here this is 1, 3, 5, and that's on the scene. That's the pipe connector, and that's the underground. Okay. So now, yeah, we triggered that. Okay, there are a few things missing here. One is we would like to have a pipe here. So add a pipe. And let's see, how big should it be actually? Let's do 160. And for the position I did, let's see how can we place this actually. A little bit down. Not the scene that I wanted. Okay, so the X should be the same as the pipe connector. So 163. See, 163. I mean, not really, because it's bigger, right? Okay, now it should be okay. Yeah, and just a little bit further, I mean down. 1 to 2. Oh yeah, and you can see that this, you can see that how do you call this? There's a technique for the pixel art where you add this shapes so it seems like it's more 3D. And this is because our pipe is not repeat enabled. Okay, now if we run our underground, it should repeat itself. Yeah, okay, so now that looks good. Perfect. So what we need to do is now traverse back to the main scene. So we need to set up how to do it. I'm going to take that pipe, I'm going to switch them around a little bit, and I'm going to take the transform here, so copy value of the transform, and I'm going to go to underground, and here in the pipe connector I'm gonna pass those values as a return point, and then I'm going to go to a player, and in player script we have to handle the pipe entrance. Okay, so let's see, we'll set the physics to false, and we'll go and do another twin. What is wrong? Use of mixed spaces and tabs. Okay, get. So now we'll do the twin that will play when user is entering the connector. Create twin, pipe twin, twin property, self, position plus vector 2, 42, 0, 1 second. And when we're done, so on the callback, we will switch to main. So let's write that function right now. Let's see. It's going to be easy, rather easy. Get free, change into file. Oh, come on, main. Okay, but we must remember about one thing when switching back. Go to the pipe connector. You remember that we set the scene data to be our return point. So now I believe we should handle this in our ready. So do we have a ready function here? I don't think we do. So let's go to the top. If scene data return point is not equal to null, global position should be equal to scene data return point. Okay, let's see whether we can make it work right now. So go to underground, play current scene, and I'm traversing. Yeah, and now, yeah, buddy, I'm back there. So let's test the whole flow. I'm going down here, and I'm spawning right here, right now. So this is not ideal because I should spawn right here. But other than that, we're good when it comes to traversing the scenes. So let me check that real quick. Why are we being put there? Is this because of... I believe that might be because of this, right? So disable that, go to underground, disable that too. And of course, we just crashed in the... yeah, in the main. Okay, so I restarted, everything provided values again. This is probably because I'm using beta version. You could try that with 4.1 or go to 4.2 release candidate and see whether this issue occurs. I hope not. So we disabled the ready function. So let's see what's going to happen right now. So I would like to go to the underground scene and run it. And we of course also lose camera sync information. So put it here and in the main scene also. Now we have that. Okay, so underground, velocity x, speed and data. What? Speed times nil. This shouldn't be... oh, now, damn it. 145, 145. This is just stupid. Okay, yeah, so this is the problem, right? So let's see how we can fix this. It's not equal to null, and I'm gonna assume scene data return point is not equal to vector to 0 because it might default to that. Yeah, okay. Now we should be good. Okay, so let's test this again by going back to main. So we're going through here. And now we're going through here. And one thing that we have to add is the collectible coins. So let's do this because this is the reason why we're going underground. That's going to be real quick. Area 2D, add a sprite, and this is going to be just coin underground. Okay, add a collision shape. Make it capsule. Disable snapping. Oh, I'm gonna say this is fine. Change the name to collectible coin. Add a small script. Change the naming to snake case. Okay, and there's nothing here in particular that's gonna shock you. We'll just connect to onBody entered. This and this. And it should be class name, of course. If body is player, then Q3 but also we need our level manager here, and we can take it from main. Okay, is it still in a group? Yes, it is in a group, so I can just say get 3, get first node in a group, level manager on coin collected. Yeah, and pretty much that's going to be all. And then if we go to the underground, I will add an empty node, call this coins, switch to 2D, and just spawn a bunch of coins here. But not the coins. Collect. Excuse me. It should be called. Didn't I just write it? Collectible coin. Oh, it's unsaved. Okay. and then I'm going to just instantiate collectible coins and a bunch of those. So let's start bringing those bad boys in. Okay. All right. So now if I'm going to go underground, I should be able to collect these. Yeah. And then go up. Okay, so we have our underground level done. I believe there are only 3 more episodes to go, or at least that's what I'm hoping. So 3 more sections, sorry. Okay, I believe we have 3 more to go. So yeah, let's add the smallest possible UI that we can. And again, if you'd like to build a complete UI, like with the timer and stuff, I believe this is something you can do on your own. So let's go to main, and I don't know why my shortcut isn't working, but we'll add UI. So add a child that's going to be canvas layer, call this UI. I'm going to immediately save branch as scene in scenes, go inside, and I believe now it's time to start adding stuff. And this is going to be, as I said, extremely simple version. So margin container, make it span across the screen. Then in theme overrides, I'm going to add some overrides. So 888, add box container, align it to the top, and here we'll add 2 labels, 1 and 2, and one will say score. It's like 0000, and so that's going to be on the top, and that's gonna say points like 000. Okay, perfect. Let's add a separation here and set it to 42. Select both labels, go to theme overrides, fonts, quick load the font that we have, font sizes. Let's set this to, I don't know, 16, 17, 18, 20. Okay, also let's add a center container as a child of the margin container. Again, make it in the center. Add a child, add some panel. Here we will add the, where is it? I would like to add the size for it. Like layout 300 by 300, sorry. At the theme override of a style, new style box flat, make it, I don't know, any color you want, doesn't really matter. And then inside of it, I'm going to add a label. I'm gonna just center it. I'm gonna say you win, center and center. Change the theme overrides, font, load our font, font size like 32, or go crazy, make it 64. Perfect, and hide it at the start. For the coding, I've been recording for, I don't know, 8 hours. So I'm pretty tired, but we're pushing through. Not scenes but scripts. Add a script. This is going to be very simple. Get rid of everything. Get the references that we need. So center container. This is going to be score label, and this is going to be the coins label. Theme. Bada bing, bada boom. We have the references, and then just set score. Score label is equal to score %d %points. The same goes for set coins. Not index, int. Coins label, text, coins, %d, %coins. And then on finish, just center container visible true. This is going to be like the information that we're done with the game, and it will trigger when you enter the castle. Okay, so now to hook it up, we'll go to main scene, and in level manager that we wrote, we will do some stuff. So on coins will trigger the number of points, and we will trace, we will sort the number of coins. English is hard. And then on coins collected, I can call coins and UI set coins. We don't have the UI here, but we will have one. UI. Do we have like the class name here? Let's add one. Going back here, already we will need the reference to player. So player is of type player, and player points scored connect to on points scored, which is going to do on points scored points scored of type int points please equals points scored, and UI set score to points. So now we have glued our UI and our player and I tend to do it like this because I don't really like when player knows about the UI directly. It just doesn't feel good. Okay, let's see whether this works at all. Oh yeah, of course we have to actually pass our references. So level manager needs UI, and it needs player, and this isn't working, and I wonder why. Class name is UI. So the question is, Oh, now I didn't save the file apparently. Let's see. And nothing happened. Okay, so to test everything, I will copy the mystery box and I will change it to a coin. So let's see where we're tracking the coins correctly. Going down here. Okay, and if we go down here, we don't have the UI in the underground. So that's going to be a problem. Let's go to underground and let's instantiate UI right here. Let's drop it here and let's drop it here. Okay. So we have a coin. There's gonna be one problem, and you can probably tell the number of the coins isn't being passed through to the next scene, right? So it also has to be stored in a scene data. So what I'm going to do is not worry about this right now. You can add it by yourself, just store it in the source scene data and apply it on function. Or should I do it? Can I do it? Oh, I probably should. I should be a good developer and make it work. Okay, go to player. Just before we go to switch to underground, let's open the scene data. Let's store the points as an int. Let's store the coins as an int. And then as we're leaving this, scene data coins, we can get this from level manager. So get free, get first node in group, level manager, scene data coins is equal to level manager coins, and scene data points is equal to level manager points. And then on ready, I can say if scene data points not equals null, I can say UI set score to be equal to points and to scene data points and points is equal to scene data points, and if scene data coins not equals null, then coins are equal to scene data coins, and UI set coins scene data coins. Okay, let's see whether that works at all. Value of type string. So there's some kind of problem. Let's take a look. What is the value of scene data points at the start? And the answer is 0. Okay, so it's not null but 0. So not equals 0, not equals 0. Should be good now. Okay, so I have 1 coin. I'm going down and can't call method get first. Oh, because we switched the scenes here. Okay, understandable. Have a nice day. So we will just do that at the very end. Have 1 coin. And set coins is being called with coins is 1 coins label tag. Yeah, and this is going to happen because let's see, this is correct, but in underground we should load that first, probably, because the order matters for the tree. Yeah, we have 1 coin and now we have that sort, but we also have to do very same thing when we're switching back to main. Okay, let's try this again. 1 coin, we go down, we have 7 coins, we go up, and now in our main problem is the same. That should be above level manager. Let's try this again. Cool. And yeah, we have that value stored. Okay, so for the points now, we should get 100 points, but we do not. So let's see. In a player, we should have something like spawn points label, and here if we spawn points label, we should get the access to level manager. Get free something group level manager, and we'll say level manager. I believe this is on points scored. And here, but I believe there's other problem because we're also in stomp degrees. We're also doing that in here. $100. Okay, let's try this again. 100 points, perfect. I go down, I still have 100 points. I go out, and I still have my coins and my score. So yeah, this is the UI done. And in the next section, we'll actually try and build the complete level. So I see you there. Okay, in this section, you will see me try and use everything we've built so far to create level 1-1 in Mario World. It's not going to be pixel perfect, but we'll try to get pretty close. Pay a special attention to how I am grouping the nodes that are building the level. I'm going to create an environment node and then add a decoration, mystery boxes, platforms, pipes, and other entities there, just to keep everything rather well structured. And it is important to keep your tree of your scene well structured so that it is readable and you can change the stuff easily there. I'm gonna speed up this part of the video because it's just me placing stuff and trying to position everything correctly. So yeah, you can follow along and or go ahead and create your own level. We should have one additional enemy here, I believe. Okay. And there's gonna be, yeah, there's gonna be one of the issues that we have to fix, which is our enemies are traversing through the pipes. So this is the level pretty much built, but we have few things still to add. Like fixing the enemy traversing the pipes. When should actually enemy start moving? And player falling down and dying. So we're gonna handle this in the next section. Okay. So first issue that we have to fix is how do you go to our enemy? I'm missing some stuff here. So let's also open the enemy scene or Goomba scene, and we have to connect to on body entered because the pipe is a static body. So let's grab this and let's go to enemy and just do if body is pipe, horizontal speed times equals -1. So this is the first thing. The second thing, we also have to connect this for koppa. So body entered. Okay. We have some issues. It shouldn't be a problem, really. So now let's see whether our enemies are behaving correctly when they come across the pipe. No, still not. Okay. Let's see why this might be. 1, 3, 4. Okay, the pipe is an obstacle, so the enemy, the Goomba and Koopa, has to collide with the obstacle. Am I right? I think I am. Let's try this again. And here he is, bouncing off of the pipes. Perfect. Third thing, they should only start moving when they are on the screen. This is another thing to add. So go to enemy, and in the enemy on ready, we'll say do not move. So set process to false. But then when we enter the screen, this is for Koopa, but we can just copy paste this to enemy. Only start moving then. Okay, let's try this again. And we also have to connect this. Okay. So he's moving, and then only as it become, yeah. Now it is moving correctly. Okay. What else are we missing? If the player is falling down, then when the player is falling down, then he should die. So I'm going to create a very simple thing, new scene. I'm going to call this, I'm going to use area. I'm going to call this fall down area, and I'm going to add a collision shape for that. And I'm going to set the shape to be of 150. Hold down area, saving scenes, and then I'm going to add a script. And I'm going to call this class name fall down area. I'm going to say that this could be an obstacle, and listen to body enter. If body is player, body die. Okay, and let's place this in our main PSCN. Okay, so we should place it here, here, and here. So let's add new empty node, fold down areas, fold down area and place it here. You don't have to be precise. Here and here. Okay, let's quickly test it out. So let's grab the player. Okay. Cool. What else do we need? I'm forgetting something. Oh, we didn't add the the decorations, right? So I'm gonna speed up this part of the video where I'm adding those decorations to make our wonderful level look very nice. Okay, that should make our level feels more alive, right? So yeah, now it just looks like Mario. Cool. So the last part is going to be hopping on the flagpole, and we'll do that in the next section. This is it, the grande finale. Okay, so to make it work, let's first go to the tilemap and just add one single block, hard block, where you would like your flag to be. I'm gonna say here is fine. And then we need to work on our flagpole. Okay, so this is going to be rather simple. Let's create new scene. Let's use area 2D because I love it. Let's add a sprite and another sprite, and let's do flag sprite, flag pole sprite. Let's see, we have a flag here and we have flag pole here. Let's position it correctly. Why is that not working? Let's change the flagpole to be here. Let's actually see how it is positioned. I want those to start and end here. Okay, then let's change this to be a flag with the collision shape. Okay, let's see. New rectangular position shape. Size is 5 by 150. Let's place it correctly. Okay, that's fine. We need a simple script. Let's call this flag. Okay. and this is going to be the simplest thing ever. So as a collision, I'm gonna treat this as a bonus. Okay, flag the SCN, save yes please. So all we need to do is connect to on body entered. Check if body is a player. It should be. If body is player, then call body as player on full hit. And that was the easy part. Yeah, intend this. Because now we have to make it work. So opening up our main TSCN, we can place the flag here. Right. Now let's see. Okay, this is looking pretty good. The problem is how to do that whole animation of the, the Mario jumping on it, then doing another jump, and then moving into a castle. And since we're talking about this, we should probably also have a castle here. So let's find it. Let's just drop it here. Okay. And this, I'm not going to lie, this is going to be rather hard to achieve, but we can manage this. So what we will use, we're going to use path to D, and we'll add this to our main. So let's find path to D. Oh no, not here. And as a child of that, let's add path to follow to D. Okay, and here I need to set the points for this, right? And why would it be 0, 0? Doesn't? Okay, you have that point here. Also, the path itself. Let's actually make it make sense. Bring it here. Okay, where is it? Disable the curve. Where is the path itself? Just here. No, I don't want to. God damn it. Yeah, and this is moving the point, so let's clear this. Perfect. Now we have a path here, and I can create new curve and start adding the points. Okay, so one here, then start moving those points. Let's disable the snapping, because I would like our Mario to go something like this. Okay, and that's good enough. Grab some water. Yeah, so we will have to reparent our Mario to that path and move it and then reparent it back. I tried to figure it out at the stream yesterday, at my first live stream. I wasn't able to, I was too engaged in the conversation, but after that I was able to finish it, which makes me very happy. So what do we want to do exactly here? Oh, we have on pole hit, and this is our starting point. for the player. Okay, so on pole hit. Let's write that function down. Let's start by printing the pole right now, and let's go to main and set our player at the very end of our level. Oh, let me move you. Shoot. And let me place you here. And you're falling through the stairs. Because why? Because you don't have the physics layer. Okay. Okay, now it's better. I'm jumping. And yeah, okay. We have that pole, but I like to make sure that we are able to jump to the pole from the steps. So I'm going to bring it closer, and I'm going to get rid of that, and I'm going to select the pole. It shouldn't be here, but should be here. Let's close this. Bring it closer. Take the path. Get rid of that and just move it closer too. Okay, let's try this again. Is it good enough? Okay, let's say it's good enough. Okay, and then we can start coding our on pole hit. Okay. This is going to be nice, but set physics process to false. Set the velocity to vector 2, 0. We should also add another flag here. Is on path, and we'll set it to false. And then here, if is on path, we'll return. Then we'll call animated sprite 2D and call on pole player mode, makes us go here, which makes us go here, and write that function. It's going to be super easy. Pass the player mode. Animation prefix is equal to player. Oh, we are smart enough to just copy paste it. Okay, and play. Pole. And animation prefix. And let's unindent that. Okay, so that's first thing that should happen. Okay, yeah, we're playing this. then going back to our player, and on pull hit. Player on pull hit. Paint that. We will start the slide down tween. So because let me see, do we need this? Yeah, because we have to slide down, right? So a var slide down tween is equal to get 3, create tween, or maybe you can be smart about this. No, let's do it this way. I'm too tired to be smart right now. Slide down position is equal to position, and slide down position y equals -16. Slide down tween property self position, slide down position, take 2 seconds, slide down tween callback, slide down, finished. And for now we will just do minimal thing here and say slide down, finished. Print the book, slide down, finished. I mean, just slide down, finished. Okay, let's see where that works. So I would like to not go up, actually. Let's try this again. Okay, it slides down just a little bit, which is not enough. So let's see. Slide down position is a current position. We go down, but actually we shouldn't go down, just there. We should rather, I'm going to add a marker. And I'm going to call this slide down finished position. And I'm going to put that position right where the path starts. So 0 -8. So this is going to be 311848, if I calculate this correctly. Yeah, perfect. And then I am going to pass this to a player. So let's go to onReady. Okay. Then I can just say here, the position to which you should slide down is slide down position. So let's try this. Okay. Okay, it's here. The problem is going to be if we jump too low. So everything can be adjusted. Grab both of these and let's bring them down like this. Okay, I'm gonna say this is fine. We could also calculate the distance between current position and adjust the tweening time, but this is fine. We have to move on. Slide down finish. What we now need is trigger a different animation here. So we have animation graphics here. No, but we can go into player, go into this, grab the animation prefix, go here and say this is the prefix. We will set the is on path to true. We'll say animated sprite 2D play jump animation prefix, and the most important thing, we have to reparent our wonderful Mario. So I will just go up to where we export stuff and say export var castle path follow 2D, go back to the main. Castle path is path follow 2D. Remember to put the path follow 2D here, not path 2D. So the child of the path 2D. And with that, we can call reparent to castle path. And we know that we're on a path right now. So we need to start moving along the path. Right. So I'm going to the process. And here in the process, I'm going to say if is on path, then do castle path progress is plus equals delta times speed divided by 2, and if castle path progress ratio is greater than, let's say, point, and now 97 maybe, then say is on path is equal to false and just land down. Okay, and we will go to the bottom again and add the land down function, and for now it does not print land down. Let's try this. So we're sliding and we're jumping, but I don't want to rotate, so go to path follow 2D and disable the rotation. Other than that, it was pretty good. Let's try this again. We're sliding down, we're jumping, and now it's time to land down. Okay, so in the land down. Oh my god. Okay, yeah. We're so close, guys. We're so close. Let's reparent this to get tree root get node main. This is the first thing. Then we should be having something like a land down marker. So in the main into D, I'm going to add another marker. I'm going to call this land down marker. I'm going to position it precisely where the path to the ends, and precisely where the ground underneath the end of the arrow starts. So about here. And I'm gonna get the reference to it. So it's going to be like, just grab it, land a marker as marker 2D, and we can go to land down, and we're almost done. So we're reparating this. We will calculate the distance to the marker, and it's going to be land down marker position. We just do the Y minus position Y land tween, another tween just to land down, create tween land tween property self position position plus vector 2 0 distance to marker minus get half sprite size and 0.5 second. So where we land, actually the position is going to depend on whether we have a big Mario or small Mario, and we need that function to simply calculate this. It's going to be super easy. Let's see. So return 8 if player mode is equal to player mode small, else 16. Okay, and then we will add another callback, so we'll just can we just, oh no, we can't change it. We can change it. Okay, land tween callback go to castle. Okay, and I'm just going to, as per usual, go to castle. Okay, let's continue. Let's see whether we are landing down. And oh, it should be a functional reference. Let's try this again. So I'm sliding down, jumping, and I am landing, and we're going to the castle, bitches. Sorry, I've been recording for 9 hours. I'm tired. So animation prefix, we can get this again from the tab. Animated sprite 2D, play, run animation prefix, and var run to castle. The last tween is going to be get recreate tween and then run to castle twin is going to be self position plus vector to, I believe, 16. I believe this should be run to castle twin property. Okay, let's see whether this works. We're sliding down, jumping down, and we're going to castle. We need to make him go to an entrance, so let's do 75, and then we can finish. Twin, callback, finish, and on finish we will just do QE3. Castle will emit a signal. Castle entered. Castle entered, emit, and in our level manager on ready, I'm going to say player castle entered connect to UI finish, or we have that already, UI on finish, and this is a function reference. Okay, let's run this. Jump. You win. Yeah, buddy, but there's one more thing that we have to test to make it work, to be sure it is working. Let's just go and grab our player, put them here, copy that mystery box and switch it to Shroom or maybe a flower, because we need to know how it will all behave when we have different size of Mario. And I hope it's not gonna crash and burn. No! God damn it! Yes! Okay, let's take our player to the very start and let's try running through the underground. Okay, so I'm going to do one thing here. It's going to be boop, going big, and I believe this one is traversable, or maybe this one. Okay, so which one should take me down? This one, right? So okay, I am going down, but not in a correct way. Here we're missing the pipe. I don't know why. Okay, so let me think about this. Yeah. In a player, when we handle pipe collision and we switch to underground, we create that twin. We just say how do we do this? Ordering z index. This is just set index. Okay, Set this to -3. That should be one problem done. Going to underground. What happened to my pipe? Excuse me? Why are you not rendering? I have no idea what happened here. So I'm going just to add another pipe. Not in the coins, but here. And this is strange. Like, what? Do we have some errors? Slide down, finish position, land down marker. Is this because of that? Yeah, okay. Just to make it go away, just create any markers here, it doesn't matter, and they are, let's see, they are on ready, land down marker, and slide down finished. Oh well, okay. Not using it them here, so it doesn't matter. Slide down, oops. Slide down finished position and land down marker. And we should make those optional, but this is what it is. Okay, no errors here. What is going on with those pipes? Do we have order? Okay, oh, I know. This, yeah, the ordering that we set. So I want to get rid of that. Okay. Let's try this again. And here, I'm going down. I am taking some stuff. Going through here. Okay, the position in which we should go out. Main. I believe that should be this one, right? Okay, so the position for that is 266456. Copy value. Go to underground. And provide it to a pipe connector. Let's try this again. Yeah, and we can die. Okay, cool. Let's try and finish that game. Oh my god, it has been so long. Should be able to jump there. Okay, perfect. Okay, I don't know how long it was, but we're done, boys. And I'm so tired. I still have to also render that video and post it. And I will try to do it right now. I have to maybe rethink how I am doing tutorials, because that was definitely too long. Maybe the next ones are going to be split into different parts. We'll see. But here it is. That's a Mario in Godot. You should be now pretty much familiar with how to do a platformers in Godot after that one. I'm sorry if there are any discrepancies with the original game, but it will be definitely too much to implement. I'm sorry if there will be any errors. I really plan on to starting a Discord server where you can go and help each other out with any problems about the tutorials and go all over. So we'll see about that. It takes long time to prepare those tutorials, and it takes many hours of coding, me figuring stuff out, and then many hours of recording. So I plan to start something like Patreon or Coffee or YouTube membership. So maybe you guys, if you find those values, maybe you could tip me something for all of my hard work. Thank you very much, and I'll see you in the next one.